Hello and welcome to our third video on differentiation. Today we're going to be doing an example problem with MVT and IVT. Hopefully you've watched my previous video explaining a bit more about these theorems, and today we're just going to get straight to applying them. So, okay, we have here. So the fewest number of times at which L prime of t must equal 0. So first, right, I think it's important that when you're approaching a problem that you don't know what you're doing, like you don't know what to do immediately after reading the problem, you take some time and you just start writing things down. Start writing things down that may or may not be relevant. So over here, what's the fewest number of times at which L prime of t must equal 0? Okay, so we can't quite use IVT here because it's asking for L prime of t and not L of t. But maybe we could first sketch this just to get an idea of what this table looks like. So we've got 0, 120. Again, this is not super to scale, and you shouldn't spend too much time making this to scale. Oh, okay, whatever, it's fine. So 1, 3, 4, and then 7. So 7's maybe over here. It's 150, and just getting a rough, feel for what this graph looks like. And of course, at t equals 9, there's nobody, because tickets have sold out. So our graph sort of looks like this, right? Now, obviously, no guarantee that it's going to look exactly like this, but it might. This is one possible graph that will pass through those points. And so what do we notice here? Well, fewest times at which L prime of t must equal 0. So let's look here, and where are we equaling 0? So this is the graph of L of t, right? So L prime of t is going to represent the slope of the tangent line to this graph. So I see one right here, and I see a few. So I see 3 in this graph. Again, this is an ideal graph that I've drawn that may not actually represent the function. But in this graph, I see 3 points where L prime of t equals 0 because those are all horizontal lines. Horizontal lines, of course, have a slope of 0. So, okay, great. So maybe we can start with our answer and say 3. Just take a guess, right? Of course, the AP graders will not accept just 3 for an answer, but based on this sort of rough sketch that we've drawn, I think that might be the answer. So now that we've gotten sort of intuition, a feel for the problem, now we can start, sort of formally explaining and proving that indeed we are going to see 3 times where L prime of t equals 0. So what do we notice here? Well, what do we notice at the position of each line? Well, right here, right, this ideal graph was increasing. I'm going to put that as a plus sign. So this is the sign of L prime of t. And then over here, right, after this line, it was decreasing. Right, so generally speaking, we went from some sort of increasing to some sort of decreasing. Okay, well, some sort of increasing. Can we formalize that? I think this is the point 3. Yeah, again, totally not to scale, but that's okay. So here, right, we notice from our table it was increasing up to here, was increasing up to here, and then all of a sudden it started decreasing after 3, right? It's sort of, again, it's just a general trend. So, okay, what can we do to sort of prove that maybe we're increasing at least some point right here, right? Because maybe if we can get information about one point here, we can get more information later. And can we do that? Yeah, we can. We can use the mean value theorem. So we know that L of 3 minus L of 1 over 3 minus 1 is greater than 0, right? And this is the average rate of change over, here I'll draw the secant line to represent this, the average rate of change over the interval from 1 to 3. So be something like this, right? So we know that that's bigger than 0. So we know that there is some point right here in 0, 3, right, this is 0, where we are increasing, where L prime of t is greater than 0, right? And that's by mean value theorem. Okay, that's cool. And we also notice that our ideal graph is sort of decreasing, but with a similar logic, right, we know that L of 4 minus L of 3 over 4 minus 3 is going to be less than 0, right? So that's this interval right here. And so that means, since we know that this average rate of change is less than 0, we know that by mean value theorem, right, there is going to be a point, there will be a point where we are actually decreasing, right? So okay, that's cool and all, but like intuitively, right, we need to sort of prove that there's going to be a transition from increasing to decreasing, right? Because like generally we know this is twice differentiable, so it's continuous. And when you're drawing a sort of continuous and also differentiable function, right, you need to have, if you're going from, you know, positive to a negative slope, or even from a negative to a positive slope, right, like just drawing it will quickly like lead you to realize that, yeah, there needs to be a point where L prime of t is 0, as long as you're going from, as long as L prime of t changes signs somewhere. All right, if we know that L prime of t changes signs somewhere, then we know that we are going from increasing to decreasing, and we know that in general we'll have a point with a slope of 0. Now keep in mind, the differentiability is very important here, because otherwise you can just draw a graph that looks like this, and boom, it's not differentiable at this point right there, but it goes from some point is increasing, some point is decreasing. So, okay, now we sort of know a little bit more of what we're after. So now what? We know that it's greater than 0 somewhere over here in 0, 3, and we know that it's less than 0 somewhere over here in 3, 4. So we can use IVT, right? Because we can say that L prime of t is greater than 0 somewhere. So just to recap what we learned here, somewhere in 1, 3, and L prime of t is less than 0 somewhere in 3, 4, or 4, 3. And I guess you should technically use open intervals here, just because that's what the mean value theorem says. So I'll change those to open intervals. And you may not want to use this exact terminology in your explanation. I'm just sort of abbreviating this so that this video doesn't take too long. So, okay, so we know both of these things by mean value theorem, right? So that means that by intermediate value theorem, oh, and remember to check for the condition, right? So mean value theorem, are we continuous in this interval from 1 to 4? Yes, we are, right? We're twice differentiable, so we've got to be continuous. And are we differentiable in this open interval? Yeah, of course, right? We're twice differentiable, so it's at least going to be once differentiable. So we know that those two conditions are true, so we know these are true by mean value theorem. And now we can use intermediate value theorem, right? IVT guarantees a value of t somewhere in 1 to 4, right, where L prime of t is 0. Right? If you want, if this still doesn't make sense to you, you may want to, well, let's just like briefly graph what this is L prime of t, right? And so basically what we're saying is, like, if this is 1, 3, and 4, right? We're saying it's greater than 0 somewhere in this x range. So maybe, I don't know, maybe it's greater than 0 over here. And then we're saying it's less than 0 somewhere in this x range, right? So maybe I'll make that 0. Maybe I'll draw it right here, right? And we're saying that since L prime of t is continuous, right, which you would want to say L prime of t is continuous because it is differentiable, right? And to be differentiable, you need to be continuous, right? And since you know that it's got to cross through 0 somehow, right? Like, I challenge you, you can't draw a line between these 2 points without lifting your pencil that passes through, that doesn't pass this y equals, or L equals 0 line. Of course, if it wasn't continuous, right, you can do all sorts of things, but you know that L prime of t is continuous because it's twice differentiable, so you can easily just say, right, IVT guarantees this. So, okay, we've done the hard part, which is prove 1, 0. So we know that there's at least 1, right? So I'll take that off as 0 is found. So now we've just got to find 2 more, and I won't write as much as we did here for the first one because the next 2 are very, very similar, right? Except for this next one, right, we're just going to say that it's decreasing, L of t is decreasing somewhere over here, and L of t is increasing somewhere in this 4 to 7 range, right? So briefly, like L prime of t is greater than 0. Somewhere I'm just going to abbreviate as SW. That means somewhere in 3, 4, right? By mean value theorem, right? The average rate of change is less than 0 there. And then, oh, sorry, switch this. This should be less than 0, right? Because looking at our graph here, right, that's what we want to show. And then it's greater than 0 somewhere in 4 to 7. Right? And I'm looking at this graph so often because it's very helpful for visualizing what we're trying to show here. Now, of course, this is an ideal graph and we don't know what's actually happening, but drawing graphs, approximate graphs of tables and just sketching what you see is usually always a good idea when you're dealing with table problems on the AP exam. So, right, then after this, we're just going to say IVT guarantees that L prime of t equals 0 somewhere in 3 to 7. Okay, right, and that's for the second 0, right? It was basically exactly the same line of reasoning that we had for the first one, except it's just inverse now because now we're going from somewhere decreasing to somewhere increasing. And the third one I'm not going to write out, right? But it's pretty much exactly the same as the first one, right? You're trying to say that, oh, you're going from somewhere increasing on the interval 4 to 7 to somewhere decreasing on the interval from 7 to 8, right? So yeah, and then you can use IVT again. And don't forget to mention the conditions, right? You absolutely have to mention that it's continuous and differentiable and all that because it says it's twice differentiable. So yeah, after you've written your explanations and all that, you should get 3 zeros for the fewest number of times. Now, obviously, it could be equal to 0 more than that, right? L prime of t could be 0 like 5 times for all we know. But we know that it has to be 0 at least 3 times. So yeah, that is what they're asking for. Of course, in this interval 0 to 9. So yeah, that's it for this problem. Just to recap some strategies, always a good idea to sketch out table problems in an approximate graph to get an intuition for what this graph may look like, and then formalize your answer from there. So yeah, I will see you guys in the next video. I hope this is helpful.